So, okay, so first thing, good morning to you all. Thanks for joining today for this webinar. Today I'm going to present you the SOLIDWORKS related to the issues that many panel builders or electrical cabinet designers are facing today, and propose a few ways to solve them. Okay, so first things first, I'm going to ask you, because that during the several meetings we had before, the only way to show to be completely sure that you can hear from your side this presentation is to actually ask you directly through this poll. So I see that all of you apparently have a good sound from the other side. I see that there's 2% of people that say that it's like probably one of you or a couple of you, no, 2% more than that, 2 or 3 people that have issues with the sound. Oh no, now it's removed. Okay, so sounds good. Thanks for that. I'm going to close this poll and continue with the presentation. Okay, so thanks for that again. Right, so today we're going through 3 phases in my presentation. The first one is going to be related with the cabinet design or the panel design, the electrical cabinet design in 2D. What tools you have available today from SOLIDWORKS, and what kind of resources and benefits you can get from that. Okay. The next one, the next one is going to be level up, meaning that we're going to take a look at pretty much the same thing, but from the 3D perspective, and you will see that the number of resources are incremented, and also the number of quality in documentation as well. And I would say that the speed of getting finished your project is also affected dramatically, in terms that it's really improved. Okay. And last will be how we can propose with the available tools today to our users how to improve the product they design today. Not just giving the right documentation with the right format and get your problems solved, but trying to push boundaries a little bit and how your product can be affected and improved effectively from those tools. Okay, right. So first thing, as I said, will be the cabinet design only in 2D. So let me go to electrical, SOLIDWORKS Electrical in this case, and I'm going to show you a project. This project is the one I'm going to use for this webinar. It's nothing really special. Well, the first thing is that it's not in English, but remember that it's very easy to customize that. We have up to 3 languages to be used at any given time, and just selecting the main language to be English, everything will be translated. It's one of the key features, I would say, in SOLIDWORKS Electrical in this case is how easy it's to change the properties and to change the parameters of your project. Okay, so from here, what I'm going to do now, is to use a new feature that was added in 2016, I believe, which is the project macro. What the project macro is a way to add a project, could be a complete project or just pieces of that project, into your new project. So it's very easy. It's just going to select the macro, the appropriate macro, and what I'm going to do this time, it's just reuse a 2D cabinet layout. Okay, so okay, I'm getting some questions from you through the chat. I will rather wait for answering those at the very end of this presentation. There will be time for you for questions, okay? Because maybe that will be answered during this session. So I will do that at the end. You can feel free to add your questions now if you like it to the poll. Sorry, to the chat. But I will answer that at the end of it. Okay. Thanks. So what I'm going to do now is to add a cabinet layout to the design here. And every time we add a project macro, we have these options here that allows the user to customize all the data that could be included in a project. In this case, I'm going to show you a couple of them. One is the name of the drawing I'm going to add in my project. In this case, it's only one. What I'm going to do is to ask SOLIDWORKS to create a new mark according to the numbering system I have in my project. The other thing I'm going to do is to link the components in this layout with the components in my project. There's an option which is associate, and what you can see actually now from your left hand side is the content of the macro, and what you can see at the right hand side is the content from the project. So I select a component from the project and it's going to be linked with that specific component in the macro. To make things easier, this time what I did was to make coincident the name of the component in the macro and in the project I have now. Okay, but it doesn't have to be like that. Okay, so what I'm doing now, it's linking my components in the project with those blocks, let's call it blocks, inside this 2D layout you're going to see in a moment. Okay, so I'm going to do that in a few more cases, like this one, K1. I'm adding that here as well. You can predefine that. So you don't need to do the selection manually as I'm doing that today, but I would like to show you in detail. So that's why I'm doing one per one. So just one more, and I will continue. Okay. So now my components in the project are linked with the ones I'm bringing from the project macro. Okay. So just finished. Right. And you can see I have a new drawing here. With, it's teeny, but I will show you in a moment later, with the 2D layout here. The important thing is that now if I check my components, okay, you will see that cap 1, which is one component I had in my project, now it's not only, okay, it's in SOLIDWORKS, but it's also in the 2D cabinet layout. You can see here, so it's integrated. All the data I took from that project is integrated inside my I took from the project macro is integrated inside my project. Okay, as you can see here for K1, for instance. Okay, so it's a very powerful feature, this one. In this way you can take any piece of project into a new project and build a new one very quickly. Okay, project macro, really useful feature, this one. This is another one which is from 17, this very year, which is Renumber the Documents. Okay, so I can go there and say I'm going to renumber that, and from here I'm going to pick a formula. Okay, in this case my formula, which is the format of the numbering, is going to be the folder name plus a counter. Okay, just that. Okay, and everything becomes Renumber, as you can see. Let me check again, because I think, oh no, Sorry, I didn't pick the right formula. Folder now. Folder plus a counter. Okay, yes. Okay, and what you can see is that you can change the numbering for the complete project or just on a specific folder in this case. Okay, I'm doing that again. I'm going to renumber just this folder because there's many users try to renumber their documents independently from a different folder. So it's possible to do now. You can see that it's starting from 1 for each folder I have in my project. Okay, so let's take a look to the cabinet layout I just bring here from the project macro. First thing, it's I would like to see that bigger, a little bit more. Okay, and you see that I got the F1, RT1. Well, all the blocks are associated with my components in the circuits in 2D. Okay, through that project macro you saw a moment ago. But I also have a component which is, if you remember, was A1 that I haven't linked to any existing component in my project. Okay, from the macro configuration you saw before, that was not linked with anything. So therefore, A1 only exists in this layout. Okay, so that's fine because what I did now was to bring a 2D layout and reuse that in my project, so I don't need to draw everything from scratch. So I can start from the circuits, let's say, from the 2D circuits, and then go to the layout. Okay, I can start from these 2D circuits and then go to the layout, just like I did a moment ago. But I can also do that the other way around. So if I open a drawing, such this single line diagram, and I go to A1, that it's only exists in my layout, I bring that from the macro project, from the project macro, excuse me. What I could do is to just insert that now. Insert, right click, insert the symbol, and I can place like here. And now this component, it's existing in my circuits, so I could connect that in the usual way. So we can use this layout not just as a consequence of the circuits, but we could actually start from the layout and then populate the circuits. Okay, this is one of the advantages of SOLIDWORKS, really, and SOLIDWORKS Electrical specifically, that there is no workflow that you need to be limited about it. You can start from any place in your project and SOLIDWORKS will take it. Okay, right, so that was from the cabinet to the circuits. What happens if now I go to my cabinet again and I need to add some components that are not in the layout yet, but they do exist in my projects. So for that, you have always this this option, hide already inserted components, and if you click this, everything it's going to disappear. So I know that there are a few components that that are supposed to be placed on the door that I haven't used them yet. So what I'm going to do is to insert those now. When I insert multiple components, I can choose the order for that. So I'm going to put it this way, S1, S2, then LT1. Okay, and I'm going to place that like here. Okay, so that will be the opposite. That's something that exists in my circuit and it's not in my layout yet, so I can add it just like this. And in the same way, I could change something in the circuits right now and everything will be updated. So if I go to here, for instance, to this circuit, and let's say I'm going to copy this piece of circuit here like this. So I got a new component, LT2. I could go to the cabinet and add it Okay, so I could go to, if I click on the hide option again, you will see that the only one that remains on the door is LT2, the one that I added. The other ones that are already there, well, they don't appear anymore. So there is no way to insert the same component twice, right? So I can place that here, and I got the 4 components. Okay. So that's what that's pretty much about the workflow. The bottom line is that you could start either from the layout or the circuit, change the layout, everything will become updated. Okay, so you don't need to keep track of what you deleted or what you added. You could actually do it immediately. Okay, any change would take effect immediately on the other parts of the 2D project. Okay, right. So but there is more about the layout. So one problem that the panel builders or the designers of electrical cabinets are facing is that apart from the layout, the connections between the components could be an issue because when the project is finished, typically what the engineers do is to print these circuits and give that to the people downstairs or on the workshop, and they start connecting the components. What that means is that the connections created here are not documented because they are created by the guy downstairs, so there doesn't exist a proper documentation about that. So if that needs to be, if there is a problem and someone else needs to go to the project and check all the projects and all the connections, it's very hard because he needs to start from scratch again. There is no documentation about it. And the other problem about that, this is a very small cabinet, but the other problem is that the connections created may not be the ideal ones, meaning that we can probably be using too much wire length. Okay, so let me show you that with an example. So in here, with the new component I created, okay, L2, the one I added a moment ago, we can check the connections. So right click, we call that wire cabling order. Okay, and if you take a look at this, you will see that L2, which is the new component, this one, L2, it's connected with LT1. So LT2 is connected to LT1, and from LT1 goes to K1. Okay, that's right. I mean, that's the connections I created in the 2D circuit, and also K1 connects to something else. But as you can see, K1 is connected twice. But if we take a look to the real position that in the layout, okay, what we can see is that K1 is here. And if I'm connecting twice, it means that I'm going to this area to this other area, which is the chassis, from the door to the chassis twice. Okay, so that means that I'm spending a lot of wire length here. It would be better to just connect from here to here once, and then internally all these components together. That would save me, some money, some wire length. Okay, so but doing that is very complex from the designer point of view. It needs to be checked manually and take into consideration the real location of the components. So it's very hard to do that. So effectively, not many people without SOLIDWORKS is doing that today. I would say no one is doing that today. Okay, but with SOLIDWORKS, what you can do is to go to wire cabling order and optimize. Optimize means that it's going to take all your components, and depending on where these components are placed, it's going to change the connections automatically. So let's do it. I'm going to click OK. Now it's going to check all my project, and if I go back to that specific case of the connections we saw before, you will see that K1 only connects to one component, and the other components, S1, LT1, LT2, and so on, are connected together. So what that means is that in here, all these components are connected together first, and then they move to another location just once and not twice as before. So I'm saving effectively wire length here and money. Okay, in this case it's a small cabinet, so it's probably not critical. The wire length is just an example, but in some big machines, or if you multiply the number of projects per year, the wire length becomes quite critical issue. Okay. So actually, when I go to visit our customers and I try to ask them what is the main benefit they get from SolidWorks in the electrical side of things, that it's, I would say, almost always the first one. Okay. Even some users say that the wire length they're saving, it's paying the software directly, just like that. Okay. Right. So I just added some dimensions because we're working on scale, and you can add dimensions to make it clear to the people that it's going to implement this. Okay. And what I'm going to do from the 2D, the last thing I'm going to do from the 2D is show you a little bit of documentation. Okay, so if I go to project, we have the reports here, and what I'm going to do is to add a filter to this bill of material, because I don't need probably all this information. Okay, add a filter, which is a new feature also from 16, if I remember well, SolidWorks 16 release. What I can do is to add a filter, and my filter is going to be for the location. Okay, so I just need to look at here at the right hand side at the location and choose the value. So I like to show the components from the main electrical closet, or the components from the chassis, or the components from the door. Okay, something like that. Very easy to create a filter, and then of course my report, it's limited to that filter, to that classification. What I'm going to do is add that now to my project, to the reports folder, and click OK. And I got my report created here. Okay. It's probably useful to have both layout and bill of materials at the same drawing. It's very easy. We can just take this table and add it to the layout, just like this, and move the things around. That doesn't really matter for the 2D layout. The position could be anything, could be any. Okay, so in this way I've got the layout with the bill of materials, and also this layout, it's being used for getting my connections in an optimal way to save wire length, which is really a huge benefit from SolidWorks. Right, so we saw the 2D cabinet design. We saw basically those 3 points: how to reuse the 2D cabinet design from a project, a previous created project, how to design from the cabinet to the circuit, or from the circuit to the cabinet. So any change in any of these two drawing types will be automatically sent to the other, and how to optimize the connections to save wire length, basically, through the optimization of wire connections. Okay. So next step is going to be about the 3D cabinet design. What the 3D can give us, what kind of benefits can provide the 3D design to the electrical engineer using SolidWorks. Okay, so for doing that, I'm going to move to the 3D side of things. I'm going to use exactly the same project. Okay, so go into 3D, open the same project. Remember that it's multi-user, so we are not limited by the number of users, just by the number of by the files. So one file becomes blocked for another user, but that's usual for SolidWorks. So I got the cabinet here, a 3D cabinet, and what I'm going to do now is to take a look to these benefits that we have in SolidWorks. Okay, so let me just go back 1 second. I'm going to take this. Okay, sorry about that. I had 2 sessions open of SolidWorks, so I just closed one of them. All right. Okay. So again, I'm going to open the same project. Right, I'm connected. Right. Okay. 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 And open that one. Right. So from 3D, what we're going to do is just that. Take the 3D side of things here into this design. In 3D, the main problem that the designers have is that there are a few things that they're difficult to manage from a 2D perspective only. Okay, the main problem would be the space that the components are using. Okay, so in 2D, if I take a look from 2D here, I got some components on the chassis, some components on the door, and that's it. But a very common problem is that sometimes the components they crash against the other. So for instance, I cannot close the door, and the only way to check that is from the manufacturing level. Once it's at the manufacturing level, they realize that it simply doesn't work. So what we can do from SolidWorks, and here you can see that all these components, and I'm going to show you that as I was the mechanical engineer, they are linked with the electrical. Okay, you can see here. What we can do from the 3D is actually check that. Okay, so what I'm going to do is to go to evaluate and check the interference. Okay, in this case, the interference, I'm not going to include the connector, these connectors here. You can exclude any specific part from your design. Okay, I'm going to exclude that, and I'm going to ignore the bodies which are hidden, which is basically the door in this case, and I'm going to run the to exclude the components. I need to do it here. So this one and this one. Okay, so I'm going to run the calculation and check what we get. Okay, so this is what I was talking about, that it's something that we cannot manage from 2D only. Okay, and what I can see here is that I got a few problems, a few interferences. So let's check them. Okay, you can see one. I will try to move things a little bit around, but you can see that there is a problem with this component and this component. They are crashing here. So if I was only a 2D engineer, let's say 2D electrical engineer, I wouldn't realize that there is actually a problem until I send that to the downstairs, and they try to implement all that. They try to build it around. Okay, but I can get this information in advance. I see there is a problem here. I see there's another problem here. It's the same component. Actually, it's another problem. There are some other problems that we're going to check. Okay, and it's actually for this, the terminals. You can see that the terminals, they have a problem. That won't be really a problem. This is just because this part of the terminal, it's flexible. So it's the part of the terminal that is going to be latched to the rail. Okay, so that's not really a problem, but it's showing me that anyways, which is good. What I can do is just say, okay, I'm going to ignore this. I don't need that. Okay, that's not real problem. And there is another interference here. Let's take a look to it, which is here. You can see that one. I like that one because, you know, it's like this first component. It's pretty obvious that it's going to be against the other, but that one is just for a really small part in here. You can see that it's really teeny, but it's showing me that also. Okay, so okay, I'm getting all this information, so what I'm going to do is to cancel this and fix it. Okay, in order to fix that, let's move to a better view like this. Let's take the okay, all these components that I just removed, get that back, and I'm going to move these components away a little bit. Okay, this one is fixed, so I'm going to make it float to be able to move it, and select those components in here like this, and move that component a little bit downwards like that. Okay, the good thing about that is that I could be very specific, and actually I could check the drawing from the 2D, the drawing that the 2D user created, with the distances if I have to. Okay, so I could be very specific, and this could be very useful to a mechanical engineer that needs some kind of criteria to position the components, so he can actually use the 2D. Okay, right, so once that is moved, I can run now the again the interference. Okay, and if everything was just fine, we'll see that. Let me exclude the connectors again. I'm excluding the connectors because there is a piece of the connector that goes inside my my component. Okay, and I will get some values there. Okay, so now the only interference left are the ones for the terminals, which is fine. I'm fine with that. Okay, so this is a real benefit we get from the 3D. We can advance the problems in manufacturing thanks to the 3D environment, which is something that from the 2D it's impossible to achieve. Okay, we simply cannot do it. Okay. All right, so let's go back to PowerPoint 1 second. So from the 3D cabinet design, what we can do is associate or add components to a 3D. This is a part that I skipped. It basically means that you are connected to the 2D design any given time. So the components in 3D, the components in 2D are always connected. It's something that we always show from very basic demos. That's why I didn't include that in the demo live, but it's definitely something. It's a real benefit in the 3D. Everything becomes updated like it was only 2D, and this is something that you cannot achieve with any other tools in the market, because the best thing you can do is to export and import manually, which is not really what we do. Okay, and the interference detection, of course, you can check how the components are inside the cabinet, and they fit or doesn't fit, which is a real problem we get from users. They have they spend a lot of time on that, a lot of time. So what about the product innovation? Okay, so the product innovation, let me close this for a second, and I'm going to open a different project, this one. Okay, so what we mean with product innovation, it means that there is a few things that we can do once we have the 3D design. Okay, so we talk about in the 3D design that there are some parts of the design that are difficult to manage from the 2D perspective only, And one of the things, and this is also coming from a customer, one of the real benefits is that as you can have a very precise 3D situation of the components, you can actually improve your design. This particular customer, what they do is, what they need to achieve was to reduce the space of their design. So you can see a picture here. This is my previous cabinet, the one I showed you before, and this one here is the same project with the same components, but using much less space. Okay, so what I did here was to, let me remove that, and what you will see that in a moment. Okay, what I did was to move a few components around. Okay, you can see this. I hope you can see this here. Okay, so in the previous version, what I had was basically 3 levels here, 1, 2, and 3. Now I only have 2 because this component at the bottom, I moved that to the back side of the door. Okay, because I could use actually that space for the components. Okay, so wait, I'm getting a few questions here. Okay, I'm just getting more questions. I will answer to that later. Okay, so this is very difficult to handle again with only 2D, because in 2D you could have the door view and the chassis view. Okay, no problem about that. You don't have the distance between them, so you don't know exactly if they are going to crash one against the other or not, but okay, you can do it. But what about if you're using the door like here, and you have components one side and the other side, then you need to create like another let's say view manually. So that's quite complex to do and quite complex to maintain. Okay, so with SolidWorks it's very easy. It's just, you know, move that from one to the other side, and from that you can improve it and reduce the amount of space used very easily. Okay, in doing that you are actually improving your design. Okay, so one of the problems about the electrical is that many times it's very difficult to generate the documentation. Okay, so let me go back to show everything. Okay, all the component. But in SolidWorks it's very easy to create this documentation in, you would see, a couple of minutes. Okay, so what I'm going to do is just to create a drawing. Okay, so I create a drawing from this project. Okay, this doesn't belong to electrical project, no problem. Okay, so I can do it from here. Create a drawing. Okay, I'm going to take a 0 because it's, you know, I don't know exactly how big it's going to be, so I like to keep that in a bigger space. Okay, and right, so I can use this now. Okay, so from here what we're going to do now is to create these views in this space. Okay, I'm going to take my assembly and I'll take some representative views of this project. So left, let's make it bigger because that's going to be too teeny. I'm going to change this view to something bigger, like I'm using 1.5, I'm going to use 1.2. Okay, it's probably too big, but we'll see. We can change that later. Okay, so left here. Okay, I can generate the front. Okay, like that. Very good. I don't want the details inside of sketches and all that. I'm going to select the view that shows the internal components as well. Okay, like this. Okay, and again, if I need to generate that in 2D, it's really complex. If I need to generate that from manufacturing, it's really complex because I need to to create two views like this. And also, what about the back side of the door? What about the chassis? What about all that? Well, with SolidWorks, it's really easy, because I just need to go to create a section, and I can create a section here, right, such this, okay, and I got the cabinet, okay. I could do the same thing with the back side of the door, and I got it here. Very easy, very quickly. If I change anything in the 2D or in the 3D, this will be automatically affected, okay, and you can generate that in a few seconds. But not just that, I could go and add, let's say here, add some marks, okay, it's telling me that I need to save that, no problem. I can insert the balloons, and I can insert the balloons here, and I can insert the balloons here, okay. So I have all the sorry, I just canceled. Insert balloons here and here and here, okay, like that. And then insert a bill of materials from here, and I got the bill of materials here. So we can go down and check it, and you will see that I got all these components here with balloons, and here the bill of materials. You can see that the bill of materials is showing me the part name, let's say part number. You can obviously customize this. That's my format, but you can use your own format, okay. A description, the manufacturer, and part. There are a few parts in my design that doesn't have manufacturer defined. That's because I didn't define a manufacturer for this. One case could be those you can see here from 14 to 18. These are parts that belong to the cabinet. So I'm not really interested on that, to have a specific part for it, but it's being displayed anyway, okay. So in this case, you can get a very good documentation. We could even add some bill like that to make it more realistic, if that helps to the manufacturing procedure. But you generate that in a few seconds. If you try to do that in 2D, it's really difficult, really time consuming, and you're prone to create many errors, believe me, okay. At the end of the day, many people just don't do it because they think it's just too much work for the benefit they get. So they leave all that downstairs to the guy which is implementing all this cabinet and connecting all the components, which is fine, but always you're going to spend more wide length. You're going to get some features there, some aspects of your project that won't match with the 2D documentation. So that's a problem. In this case, everything is controlled, everything it's saved, okay. Another thing and great benefit from SolidWorks is that from 3D you can do anything. You can, the 3D user have access to all the options inside electrical, so you can generate a report, you can do anything, okay. And to do it very easy, very quick, okay. Right, so I had a couple of things more to show you. Let me go back for the PowerPoint, okay. Product innovation, okay. So basically the idea is that we can generate better documentation and faster, okay, and help the user to improve the design in 3D. In this case, the example was make it smaller, okay. So I'm improving that design in that area, but it could be in many other ways. The bottom line, the concept will be that I will be able to adapt my electrical design better to the machine or to the facility where my electrical installation is going to be, thanks to a 3D design, okay. So as I said, I had a couple of things more to show you, but I think there are a few. I'm getting a pretty good list of questions by now, so I'm going to the questions. But before that, let me just send you a couple of polls more. Okay, so if you can answer those polls very quickly. What I'm going to do is going through your questions, the list of questions, which is growing pretty big. Okay, and okay, so you can see people is voting here. Okay, we're going to wait a few seconds more until you have all voted, and then I will continue with that. Okay, and try to go through all your questions today. Okay. Okay, so I can see that it's like 3/4 of the people there already answer. So if you could just pick your option from there, that would be great. Okay. And in the meantime, I'm checking the questions. Okay, I'm having here, which is a pretty long list, by the way. Okay. Okay, I'm going to wait a few seconds more, so the ones among you that haven't voted yet, you can do it. And I'm going to answer the questions. I'm going to start from the last one to the first, going backwards on my list. Okay. Okay, so let me close this poll, and there's another one that I would like you to answer. And in the meantime, I'm going to check these questions. Okay, so I'm getting a question saying that that is asking about combining this SOLIDWORKS with some other softwares out there. The answer is that yes, you may combine that with other softwares in the market. No problem about that. The only limitation about that is that the data we get from them. I mean, they could probably export that to a DWG format, and we can get that DWG inside our system. What I'm not sure is we are not sure is that all the information will be included in that DWG. But apart from that, it will be always more limited, more restricted than if you're using only SOLIDWORKS. But yeah, there's nothing against that. Okay. Okay, so okay, there's another question. Can you place the components in a place you want in the cabinet? The answer is yes. You can place them anywhere. There is no restriction about that. Okay. Wire splitting, crimping it with a splice or welding in somewhere in the root, because a device can receive only one wire. To crimp a wire, change the route of your wires. It's not difficult. I mean, it's a standard routing tool. If you're interested on that, you can contact your reseller or directly to SOLIDWORKS, but always through the reseller, and we can show you how to do it. I mean, the routing always goes from A to B, but obviously you can have intermediate. Thanks for asking the poll again. You can have intermediate points for this route, so that won't be a problem. I'm reading the other question. Is that the spacing, not just physical interference. Okay, I show you how to check the physical interference, but it's true that sometimes you need some extra space around that for your electrical components. Okay. This can actually be easier, and let me show you that from SolidWorks, from 2D. Okay, you can achieve that directly from 2D. Okay, you can, if you take a look to my components here on the door, I included like I kept that on purpose visible. Okay, like a square in green. That's the spacing. So it means that if there is a minimum space between them that requires to be achieved, you can do it like that. Okay, what the 3D is telling you, if there is a real issue about, you know, the door is not going to close or it's not big enough to fit all your components, okay, rather than just the the space around it. But of course you can do it, and you can do that even just from 3D, sorry, just from 2D. Okay. Okay, so let me delete one of those. Okay, next one. Do we need the SolidWorks license for each electrical designer, or is that SolidWorks Electrical another software? Okay, there are two things here. One thing is the 2D. What you saw in 2D, it's a standalone license. So that works with one seat, let's say, and that's independent from the 3D. Okay, so you can keep your electrical just working on that side with this. In that case, you don't need a SolidWorks mechanical license. So I believe this is the this is your question. And for the mechanical integration between SolidWorks Electrical and SolidWorks, of course, you need the SolidWorks license. Okay. But all these licenses could be floating license. So if not all your users are going to use the license at the same time, floating license allows you to just take those when they need them. But you don't need the SolidWorks mechanical running at the same time to do the 2D only. Okay, to do the integration in 3D, yes, of course, because we are actually using SolidWorks. We are using 3D. Okay. Okay, what else? Yeah, that's a good one. It is necessary to have the 2D part. I believe that means the 2D layout design. That seems like an extra step. The answer to that is that you don't have to. I mean, I'm showing you the complete thing. I'm using all the set of tools here, so you can see, you can have a better view of all the software. But if you don't want to create the 2D and go directly to the 3D, that won't be a problem. Actually, that would be great. That would be an ideal way to do it. The 2D for me, it's if the company has 2D and 3D, the 2D means that you are going to create like a template that the 3D user can use later to position the components in the right way. Okay. Sometimes the mechanical engineer doesn't have a good criteria about where the components should be placed inside the cabinet. So that's a good way to, you know, give them like kind of a template, and not having to go there and sit close to the mechanical engineer and try to explain everything every single time. You can do that through a document, which I think makes more sense. Okay, I got some questions about PCBs. Okay, a few of them. The best answer I can give you about PCB is that we are in the same way. You can see that the 2D design and the 3D design works together. We work in the same way with SolidWorks PCB. So if you're interested on PCB design, go and check it. I think it's a really good way to add your PCB design to your project globally, and the mechanical. Okay, but it works exactly in the same way as the 2D and 3D you saw today, but it's worth to take a look to it. Will the cables be shown in 3D as well? Yeah, yes, again, yes. This is something that we show in the default demo. I'm not showing that today to you. I thought it was pretty basic stuff. But yes, you're going to see that in the 3D. And again, remember that it's not just connecting A to B. It's connecting depending on the position of the components. So again, you're really saving wire length here. It's not just connecting, it's just connecting with intelligence. Okay, there's another question about harness drawing from the electrical schematic drawing. I mean, this is not today. I was the target of this presentation was about only cabinets and wires and cables. If you have interest on harness 2D, no problem. We will be happy to create another session like this for you. Just ask our team. You will get an email from our team asking about some feedback and things like that. So feel free to contact them and ask for a webinar where we are going to show you how the harness works and how you can create a 2D drawing from it, a flattened 2D drawing from it, for sure. Okay. Some other questions about calculate the heat generated from the components, or how calculate some other aspects on my design. The answer to that is that remember that we are in SOLIDWORKS. So anything that SOLIDWORKS can do, we can actually do it. I mean, we start from data coming from electrical, but from that, the good thing about SOLIDWORKS is that it's giving you access to many other options, many other design parts available from the SOLIDWORKS portfolio. So you can run simulation on this if you feed that with the appropriate data. Absolutely. Okay, so the answer will be yes. And again, this is actually something that differentiates us from the competitor. We are not stopping here. From here, you can get access to any SOLIDWORKS product, any SOLIDWORKS part here, like the interference I use. This is a purely mechanical tool, but I'm using that in my benefit as an electrical engineer. Okay, so yeah, the answer is yes, of course. I gotta think. I find it. Okay, yeah, we get some questions about if there is a YouTube or share link, so we can review that in a later stage for more details. The answer is yes. You will get a link with this webinar recorded, so you can go back to that anytime. Okay. More. I got a question from mechanical engineer. And it's asking how well is this incorporated into product design as opposed to the cabinet design. I've used the example of a cabinet design because it's very, I think it's very useful and very quick to understand the benefits from a bigger cabinet that I reduced to a smaller cabinet. But in the same way, you can use it for not a cabinet, but some other product that has electrical components. Okay, let's say a robot, let's say a vehicle, something like that. And it works exactly in the same way. We have a few recorded demos in SOLIDWORKS.com or My SOLIDWORKS, and you can check that. Okay. More things I can see from here. Do you have a smart way of doing large cable trays on large sites? Well, the cable trays that are taking all the wires and cables through them, the good thing about that is that as the connection is intelligent, and as I said before, you can define an intermediate point for that connection in 3D. So it's not just going from A to B in a straight line. You can define those intermediate points, and one of the cases for that could be actually the cable trays. Okay. It's possible to use smart features on the components and that I'm using here from electrical. The answer is yes. Generally speaking, I have a few questions about that. Any feature from SOLIDWORKS can be used here because I am in SOLIDWORKS. Okay, I'm not importing some step file or things like that. I am in SOLIDWORKS. So anything you're using in SOLIDWORKS can be used from this point when we are and on. Absolutely yes. Okay. More questions. I got a few demands about more information about bill of materials and reports. The answer is, again, please contact SOLIDWORKS and ask for another webinar, or a specific contact with me or any other guy from our team, and we will be pleased to help you. License, I think I already answered to that one. The schematic, is it included for 3D? As I said, again, it's a different license, it's a different seat, and the reason for that is that the mechanical and the electrical engineer could work in the same project at the same time in two separate seats. Okay, so you don't have to take one license that you don't need. A question about the cables and piping and tubing. Piping and tubing, we are not doing that at this moment. It's just about wires and cables, but you don't need piping and tubing for this. You have the specific routing tools for wires and cables in SOLIDWORKS, and these are the ones you can use. I got another request for PDM sessions. Again, please contact SOLIDWORKS, and if you have any requests for a PDM session, we will try to help you. Okay. Another request for another webinar for a starting level. Again, please contact SOLIDWORKS and request that. I got more feedback. Okay, I got an interesting one here. I have 100 different cables. That's a question. And how to have 3D routing of them partially. For example, I need a few power cables, and okay, so this is very interesting. If I connect in 3D my wires, everything will be connected automatically. Okay, and it's trying to look for the shortest path available always. Okay, but what happens if I have to separate, let's say, power and control wires? The answer is very simple. We got this option here, you can see on the top that now it's grayed out. Segregation. Segregation means that you can set a few rules saying this path, let's say, it's going to be used only for power wires, and this other path only for control wires, for instance. Or maybe you can say the wire 24 volts DC is going to use this path only, or maybe it's not going to use, things like that, rules like that. So you can set all these rules, and once you run the connections, everything will be routed according to those rules. So the answer is yes, you can actually manage that. Okay. Can you have a separate drawing of each cable needed to the project? Yes, you can flatten in 3D. I guess this is coming from the 3D. It's possible to show assembling, animate, manufacturing to check whatever screws are reachable. Again, you have access to all SOLIDWORKS feature of all our products in the portfolio, so you can do anything with that. Yeah, well, I'm getting a few more, but they are basically about the same lines that the other ones, like license and all that. I think I already answered to that. I got some questions about some competitors. About that, you need to ask the competitor how they integrate on SOLIDWORKS. I cannot answer that from my side. Okay, so I think it's pretty much it. Probably I'm missing some questions, but I think that's the majority of them. Okay, so just wrapping up a little bit before finishing this demo. What we saw today, it's how we can, from SOLIDWORKS, help you build better products. and basically to reduce the scrap material and on your the new projects, and reduce the time to market, generate documentation faster. Any change in your project will be automatically spread to the other parts from 3D to 2D to, well, you saw that. Okay, and we saw that through these three different steps: the 2D cabinet design, then the 3D cabinet design, and then the product innovation, which is basically many of your questions were about this last bit of it. That it's basically to have a broader view, to be able from just the 2D or the 3D electrical design to have access to mechanical tools, simulation tools, and things like that. That allows you to get a better product innovation. And this is actually, honestly, SOLIDWORKS is the only option for that at the moment in the market. Okay, we already did some QA questions today. So again, thanks very much for your time today. I hope that it's been really productive and useful for you. That was supposed to be not that long meeting, but the number of questions I think is worth to make it a little bit longer than we expected at the beginning. And again, that will be available for you in a short period of time. And any question you may have, any request about another webinars, please feel free to contact our team and we will help you. Okay, so thanks very much. Have a good one, and I hope to see you again in the next webinar from SOLIDWORKS. Thank you.